Assalamualaikum warahmatullahi wabarakatuh and hi everyone. So in previous lecture, you have learned how to come out the transfer function from the physical system, that including electrical system, mechanical system, electromechanical system. So now after we get that transfer functions, the performance of the system can be checked by either using time domain analysis or frequency domain analysis. But in this chapter, we will focus on time domain analysis. Learning outcomes. So at the end of this chapter, you should be able to find the time response from the transfer function and then identify poles and zeros from that transfer function and use that pole and zeros to determine the response of the system. Next, to describe quantitatively the transient response of first order and second order system, and the last learning outcome is you have to be able to know the condition that can provide the higher order system to be represented as a second order system. Okay, as an introduction, analysis can be done by referring the output response of the system. So we can check the performance by employ any signal to the system. However, to be easier to analyze, step input is a right choice to be used. So before the time domain analysis can be performed, two things are required, that are transfer function of the system and input signal that we inject to the system. So the output response of the system consists of transient and steady state response. Okay, this part we call transient response and this part we call steady state response. Okay, for this transient response, so this response is a response generated by a system which is highly influenced by the nature or physical trait of a system. So it is not influenced by the input. On the other hand, this steady state response, this response influenced by both input signal and the physical state of the system, so which can only be generated for a stable system. Poles, zeros, and its relationship with system response. So poles and zeros in transfer functions are values that indirectly used to describe what is happening in a system. So what is poles and what is zeros? So how can we get the value of poles and zeros? So for example, for this system, so the pole is essentially the value of S that make the system transfer function go to infinity, where it refers to the value of S that are the roots of the denominator. This is denominator. While the zero is referred to the value of S that make the system transfer function go to zero. So it refers to the value of S that are the root of numerator. This is the numerator. Okay. Through the information of pole and zeros, this is pole and this is zeros. So the stability of the system as well as its performance can be identified. So physically, the number of poles for a system must exceed or at least equal to zero. Let us look at this example. For example, we have transfer function with Gs equal to S plus 1 times S plus 4 divided by S times S plus 3 times S power of 2 plus 2S plus 5. So the location of pole can be determined by taking the denominator part, this part, equal to 0. So by doing so, the result of pole becomes 0, negative 3, and negative 1 plus minus J2. Also same for zeros, it can be determined by taking this numerator part equal to 0. So by solve this equal to 0, so we get the value of zeros is at negative 1 and negative 4. So next, the location of pole and zeros can be plotted on the S-plane as indicated in this figure. So this one represent pole and this one and also this one represent zeros.